Share my screen. Yeah, I think you can see my screen, right, friends? So today let's complete. Mostly, we'll try to finish multi-threading. If anything is there, one or two topics, maybe we'll try tomorrow. But the idea is to almost cover multi-threading in today's class. Yesterday we had introduction to multi-threading. What is multi-threading and thread life cycle? What is start? What is run? And then similarly, how to create thread in multiple ways, like creating thread directly using a method like this and passing it as a target. Second thing, creating a thread by extending thread class to a thread itself, that is an overriding run method. That is one more thing. Like in Java, if it is Java, we must implement run method, but in Python, run is optional. That is one important point. We don't need to override run method from superclass thread. It's not necessary in thread class in Python. If it is Java, definitely it's must, because sorry, because somewhere at some level thread implements runnable interface. There is a concept of interface. If it is interface, we must override run method. So that compulsion is there in Java. But however, we don't have such compulsion in Python. Run is optional. Instead of that, you can use any other regular method, and you can have that multi-threaded nature, not a big issue. So this is one important point. So maybe you can please keep that in mind. So that is the idea. Apart from that, I believe we also have seen yesterday how to create multiple threads, and we observed the race condition example also, I believe. Right? Suppose if you can try this as well. We just tried yesterday. If it is in race condition, we cannot predict which thread executes properly, which thread executes first, which executes last. And also we cannot predict the output. So because everything depends on thread scheduler and CPU. So that we discussed yesterday. So I believe we don't need to again discuss that. If you want, you can try that. Right. So I'm just quick testing this to show you. See, we are running two threads here. So it's okay. This is fine, going on fine, no issues. Again, let's run it again. Maybe you can run again. Now you can see there is a change in this. This is interleaved output, means both threads are not executed properly. One thread had jumped into another thread. So that is what happens when you try to run two threads, because both threads try to run parallelly, which might overlap, and we might see this kind of distorted output. Of course, both execute successfully. No, no, with that we don't have any issue. But there won't be proper synchronized output. So that is what happens when two threads are executing. Okay, friends. Next after that. So let's get into the next. Today's session would be much more interesting about managing threads. We need to start. The purpose of start is very clear for us. What is that? Initiates the execution of threads target function. We had discussed the life cycle of thread yesterday. You must remember, you must get some idea about start, right? Then join. This is something we need to understand. We'll do it today. What is this join? Simple. When you call join on some thread, it causes, right, whichever thread calls this join, that will be waiting until the other thread completes. execution. So what is that? Join waits for the thread to complete execution. Okay. So this there is a optional timeout argument that anyhow we don't need that. Okay. And is alive is to check if a thread is alive, if it is running or not. And we know yesterday we have seen a program how to get name of current thread. Okay. How to set name, how to get name, all that we did. We see that yesterday. Demon will see today. Okay. So this is the example. And also this is an example which covers couple of things here. So what is that about join thing, how join works, about also active count. So there is another thing, a method active count function. So what is this function does here, active count? This function returns number of thread objects currently alive. So this is a very simple program. You can see we are not doing really something difficult to understand here. We just have two methods you see here. Got it right, friends? So in the first thing, what we are doing thread one. So we are just trying to, what is that we do here? Sleep for 3 seconds and then we are just printing. Okay, just you can do one thing. Yeah, we can run this now. You can keep that comment for print as is. We don't need to change it for now. And now what is that we are doing here? If you see here, we are trying to create two threads. You can see thread by using thread object. And then we are passing that method thread one as a parameter, thread two as a parameter by using target parameter here. These are keyed parameters in fact. Keyed parameters in the constructor, thread constructor. You know, right? If it is a function call or a method call, we can use keyed parameters, and target is a fixed key, is a built-in key. Args is also built-in. And to this args, if you want, you can pass parameters. Of course, while testing, I will remove print statements and see just it's printing. So, okay, that's all. This percentage, you can, D is something, what it says is, it's like, printing that I value here. That's all. Got it right. This is like I'll just change that instead of confusing. I'll just change to our F string here. That's not a big deal. We are just having thread one and thread two where we are sleeping both threads for 3 seconds and then printing the thread information here. That's all we are doing that. Whatever the parameter here is nothing but those are something which are passed from here to this thread one where this 10 is passed in the form of a tuple, but tuple has just one value that is passed here. Similarly to this thread 2, we are passing parameter through args. This anyhow we see in yesterday's session. Then we start threads and then we are checking active threads. Okay. And then finally we are applying join. See, many people have a confusion with join. What is this join? Very simple. So that's why I yesterday just added a clear documentation here about join, right? What happens when you call join on some thread? When you say t1.join, many people think that t1 thread is in waiting. Join generally causes a thread to wait. But the question is which thread to wait? Which thread it causes to wait is the question. Many people thinks that if you say T1 dot join, T1 will wait, or T2 dot join, T2 will wait. That is not right. So who calls this T1 dot join? Main method. Then main will wait here. Who calls T2 dot join? Again main calls. Then main is waiting here. There are three threads in this program altogether. How many? Three threads. What are those three threads? Two threads are these two, and one is your main thread. By default, main is a thread in Python, not just Python, in most of the languages. Even your main method is also a thread. You got it right, friends. So we have how many threads in this program altogether? Three threads, not just two. By looking at objects, you might say the number of thread count is two, but in reality, it is not two, but it is three. You got it right. So finally, I'm copying this. So just testing the code here. So what I do is maybe I'll just add new file, and then just say join test, enter. Okay, and paste it here. Okay, so now finally, so I should do one thing. I have to import packages. These two are important. So modules, not packages exactly. These two are modules. Okay, then we imported. And finally, what do we do? Just quickly run this now. Unexpected. Okay, I'll just try to fix it while running if any issue comes. Okay. Finally, run join test. So plus. Okay, that's not a big problem. str of I'm converting it to string to get that count of threads. Okay, and finally run this. You can see number of active threads. What is that, friends? We have 3. And if you want to see the output, we can simply put an F here and then printed by. You don't need all this. I'll just simplify this thread I, and you can close this. This should be fine. Print that I here. That is enough for us. Okay. So put single quote or double quote. Not one single, one double quote. Okay. And here also you can do one thing. Copy this, paste it here. Okay, just leave it like that. That should be fine. Okay, now we are passing 2 threads, but there is a change in value. Thread 1 has, we are to thread 1, we are passing 10 as value. To thread 2, we are passing 12 as value. That should show the difference in the output. Okay, now run the out program. Now we have 3 active threads. That shows you might get a question. So what is that question? We have just 2 thread objects. Where is this third one coming from? Your main is also a thread here. Just keep that in mind, friends. Okay, so altogether 3 threads. That should balance the count. Hope that is clear. So I hope this is clear, and you can see the count of active threads. This is what giving us. Okay, once just started, we have 3 threads, including main. And then when we call join, which method is, you can also just add print. So just all threads are executed. So this gives you an idea. What is that? This gives that main thread ends or closes at the end of this. Once these 2 threads completes execution, then main will complete execution because all 3 threads start the execution. But after that, what is happening? When you say T1.join, this is what happens. Let me just show you this with a small diagram that makes more sense. This is very important to understand. Okay. So how many threads are there? Let me open that. Come on, buddy. Okay. So here, if you see in this program, we have 3 threads. One is T1, another one is T2, another one is main. So all these 3 are fighting for processor. This is the processor, and you can think this as a T1 and this as a T2, and finally this as your main thread. Okay. Finally, now you can cancel. Now what happens? So all these 3, first main starts, definitely execution starts with main. So all these 3 threads starts execution and they get registered with the thread scheduler. And if thread scheduler allocates CPU, then one of these threads will be executed. That is fine. Okay. So this is CPU. Just write CPU. Now what you are saying join on T1 dot join, right? And you say T2 dot join. It's a very simple understanding. Then when you say join, who is going to call these join methods? The main thread, because these two are inside. If you see the code, this is inside main thread. All this code is inside driver program, which is your main. And main is going to call this. If main calls join, then main is going to wait until T1 is completed, until T2 is completed. And finally, once these two threads completes execution, then main resumes its execution. Finally, main also completes execution, and the all that threads execution is completed, so that it will stop the execution. So if you see this here, you can see here we have three active threads, including main, and you can see now first one of these two child threads are get executed. So this time T2 got executed first, and then T1 got executed, and finally main is the last to be executed. Why? Because we called join on main. So what? Because main is calling this join. Whoever calls this method, they will be in waiting state. That is what happens here. So finally, main executes once this T1 is completed, T2 is completed. So this is what happens in the diagram. Also, if you see here, who is calling this join? Main thread is calling join. So main will be waiting. So we have three threads here. So what is that? This is T1, this is T2, and now this is main. Okay, you just put like this. Now main calls, what is this? T1. Then main is waiting. This is waiting, right? And T1 might get a chance. Similarly, main is again calling this T2, right? So again, T2 also keeps continuing executing with the processor. So first these two will try to get processor, what T1 and T2, this one and this one are in race condition with CPU. Okay. Then still main will be in waiting. This will be in waiting because why this is in waiting? Because it is main who is calling join on T1 and join on T2. That means whoever calls this join, that is in waiting, which is nothing but main. Main is still in waiting until T1, T2 completes execution. Right. So these two is fighting for a CPU while main is waiting there in the queue. Got it right, friends? So finally, once these two executes completely, this T1 thread and T2 thread, and finally main will get a chance with CPU, and main also gets executed. So this is how the execution happens internally while thread is executed. So finally, if you see the output also, you can see this print is part of main method, and this is the last to be executed finally. So this is the idea. What is this target? Target is just to pass a method as parameter to a thread so that this method behaves like a thread. And similarly, thread 2 also same thing. That method also same. Args is something which is used to pass some value to the this thread methods. Got it right? So this is the idea, friends. Hope you got this. I'm just sharing this code with you. So let me share this code. So this is covering multiple things here. What is that? It is talking about join. It is talking about this active counts, active threads, and thread count. How many threads are there, including main? And finally, the execution flow, everything. Okay. Next. So this is the idea. So finally, we have understood a couple of things here. And one important thing is about join. What is this join? Very clear here. Just wait until the thread is finished. But which thread is finished? You can make the main thread wait. See this, it's very clear. You can make main thread wait until a specific thread is finished using join method. What is that specific? T1 dot join, T2 dot join. When you say this, these two will be executing while main is waiting. That is the meaning of that. Okay. So I hope this is clear for all of you friends. Now, finally, joining is completed. I think we have discussed this as well. Next, after that, daemon threads. What is a daemon thread? It's very simple. It is a background thread, right? Sometimes while your foreground thread is doing something, the background thread will also keep running. I told you a simple example yesterday. While I am doing a Python program, executing, in the background, I might keep listening to some music. So that music is a background thread, which is running the songs. And in the foreground, PyCharm is the foreground thread. Got it, right? That is the idea. Similarly, we can create a background, and you with this example gives you that idea. And this is a very simple example. We are creating a simple method background task and printing values from 0 to 4. This is a very simple method to understand with all that discussion we had. And creating a driver program, we are creating a demo thread here. How to create demo thread? While creating that built-in thread object, we are passing this method as parameter to target. And you can see setting this demo to true means this thread is created as a background thread. Demo is nothing but creating a background thread. And then you can say start, and then that thread starts T1. Main by default, we don't need to call main. Main by default starts main thread. And finally, it also says main program finished. Okay, now when you run this, you get that idea, which is executing. So find this, whatever the method you are placing, this completely acts as a background. And sometimes what happens is your foreground thread might finish, still that background thread might be executing in the background. Right? So if you see this, if you run this, this is so simple to understand. Let us do one thing. Let us create a simple program to talk about daemon threads, new Python file daemon underscore thread. Okay, maybe what you can do, you can import this, just this one. I'll just create a program so that it's easy for you to follow. So what you can do, you can say background underscore something like thread, and then colon. If you want, you can pass a parameter, or else you can directly take what is this for I in a range of you can do one thing, range of, you can just pass, if not 5 you can pass 10, it's up to you. Just for testing purpose you can say something like print. I don't think there is any difficulty in this. The background, you can simply say something like task. Okay, you can just print this I here. That should be fine for us. And finally, next one, what is that you should do now? Just create a main module. If underscore underscore name equal to single quote start, okay, underscore underscore main. Sorry, friends. Okay, you can just, that main has to be in quotes. That is important. Okay. Now create an object. How to create object? Yesterday we have seen that if you want to directly create, there are two ways we have seen. One, you can create a thread object directly, something like thread constructor, built-in thread constructor. And to this, we can use target parameter, and to this we can assign this method, and this now behaves as a thread. Comma. If you want to pass some parameter, you can pass parameter here. But of course, now I am not passing anything. Or if you wish to, you can do one thing. You can say args equal to, and that has to be passed as a tuple. Then you can pass it as some n here. That n you can pass here. So we can test it, not a big problem. So now after that, so you can put comma as a syntax. We should, when passing tuple, just say comma by comma inside tuple. And finally, making it as a daemon equal to set it to true. and this behaves like a demo thread. Now, finally, what is that? So you can, if you want, you can just say T1 dot start. Okay. Finally, you can also say print main thread finishes execution. So if you look at this, this is not really difficult to understand this. We are starting demo thread. You can created a demo thread object, pass this thread as a parameter, this method as parameter, so that this method behaves or executes in the scope of thread. Okay, if you don't pass it to this target, then this is like any other normal method. It won't be in the scope of threading. Got it right, friends? And args is something if you want to pass a parameter to that, and you can, if you want to use it inside that. And finally, last one is a daemon. If you want to make it as a background thread, then you have to create it like this. Now finally run this. You can see here, while the background thread is executing, so what is happening here? It has to run remaining 4 also. Okay, for I in so there is a small, when you are passing parameter, it takes it, but it takes this just 5 as one parameter, probably. Do one thing instead of this, pass it 5. Okay. Anyhow, we cannot pass it like that. Generally, it acts as a tuple just for your this thing. If it is a tuple, then you do one thing. So, right? This is 0th index inside tuple. So you can say n of 0 colon. Otherwise, you can simply say 0, which extracts that first value. Okay, this should work now. Uh, I will also do put a print statement. Print n of 0. That should give us 5 from the tuple, and that I am passing as a value to the range method. You know how range works. Let's run this now. So what is happening? It is saying Bootstrapper has some problem. Let me rerun this again. Okay, something is missing. Hmm. Let me correct this once. There is a slight correction here. What is it missing? Let me see. We used n directly. Okay, this is what we created already. Getting it. Okay. Okay. This just only passes one value. Okay, yeah, let's try it now. We tried this passing in. Okay, let's run this one more time. Right click. Okay, this is running now. Earlier, if you see, same code, we are passing in, we tested. Somehow we just got only task 0 running. But anyhow, you can see now, this gives you a clear idea. No problem. Mostly, yeah, same thing we did last time. Okay, fine. So now you can see here, one thing you can understand when this is the back demo thread. This is how you can create demo threads, one thing. Second thing, you can see demo thread executed till this background task is 2, and then makes, excuse me, friends. Yeah, you can see here. Then by the time this demo thread is still running, main got completed execution. Still after that, background thread is running in the background, even though main thread finishes its execution. So this is the idea, friends, about background threads. Let me share this code with you. I think this is clear about demo threads. Next one is, got it right. Finally, this parameter is important. That's all. And if you want to pass some parameter to thread, this is how you have to pass as a tuple. So finally, we are done with demo threads, how to create it, how to make a thread as demo thread, how to pass parameter, all this stuff. Okay, next after that is concurrency. This is very interesting thing, friends. And here there are two questions to you. What is that? What is concurrency? And second, see what is parallelism? And we have beautiful example here. This example gives you a clear idea about difference between concurrency and parallelism. This is a beautiful scenario. Most of the time we might have a confusion with this what is concurrency and what is parallelism. Both are two different things. So I did a R&D yesterday, a thorough R&D, and we brought in beautiful things into the discussion here. Concurrency means simple. Let us understand just in a very simple way. Simple. One CPU executing multiple tasks. Let me just show you with a small diagram. What is difference between concurrency and this one is you have one CPU, right? And in between that you have again what you have same CPUs trying to execute multiple tasks, right? So otherwise, let me do it like this. One CPU. Within that, it happens. You can see this something like this, right? And here, this CPU has to switch between all these tasks. We have just one. So it has to execute task 1, task 2, and task 3. So what is happening here? So you can just name this as a task 1 or thread 1. It's up to you, friends. Okay, task 2 and task 3. So what is this here? In this case, the CPU switch between one task to another task. You can see this because we just have one CPU here. And this involves concurrency. Concurrency means one CPU switching between multiple tasks. And this approach, the advantage is CPU is not idle, it is efficiently utilized. So that is the advantage with this concurrency model. Right. So but problem is there might be inconsistent outputs. You got it, right? When you go concurrency, right, you might miss the order. That is what happens with concurrency. We just see that here now. Let's see that clearly here. What is this here? It means system can handle multiple tasks at a time by switching between them quickly. That is what this, if you look at this diagram, it is very simple to understand. And best example, we brought in a very interesting example. Even if you have one processor CPU or one CPU, it can interleave. Interleave means switch between tasks to make seem that it is like they are happening simultaneously. You got it right. So we just have one CPU, still it will try to switch between these tasks. And in the output, we see that all are executing parallelly. But here it is not doing that. Got it right. And this is the example. This is the interesting example. A chef cooking multiple dishes in a kitchen, but we just have one chef here, not multiple chefs. The same chef is doing different things here. What is that? If you see the example, chef chops vegetables, that is one thing. And second thing, while waiting for water to boil, chef prepares a sauce, that is task two. And again, task three, he is baking the cake in between. So all this is done, sorry friends, all this is done by the one person itself, switching between each task there. This should give you an idea what is concurrency here. See what is happening. Even though chef is just only one person, they are handling multiple tasks at same time by switching between them, like as if some multiple people are working on these tasks. You got it right. I think this everyone has this experience of chef because in kitchen either we are mostly our partner. Okay, keep cooking, and you know how they works, right? They do this concurrency approach, right? So this example gives you simply you can remember, right? Someone cooking in our kitchen itself is a concurrent example. So, and how do you achieve concurrency in program? Simple. In programming, concurrency allows different tasks. What is that like reading files, fetching data, or running calculations, doing multiple things at a time in one process. That is what we do. That is what simply we can say is concurrency, right? To make progress together instead of waiting for one to finish before starting other. I got it right. If in one process, if multiple tasks are running, and that's a kind of concurrency. Now you can try with that with a beautiful example here. So what are the key takeaways with this concurrency? See here, tasks run in interleaved manner, one at a time, but switching quickly. Here, if you see, when you have three tasks, what CPU does is either it will pick task one or task two or task three. At some point, it just runs only one task, but for us, it looks like CPU is executing all tasks at a time. But in reality, CPU executes only one task at a time. You got it right, friends. So that is, these things are very important to understand and makes progress faster by avoiding waiting time because that CPU is constantly switching between the tasks. Can work even on a single core processor. Generally, in this kind of concurrency model, just a single core is enough. If it is parallelism, we need multiple cores. We will talk that when we jump to that example. Just one core is enough here. That core thing also we'll see. These are all very interesting things, friends. And let us see the example. See the example here. Again, simple. See, this whatever the code snippets we documented, these are very simple things. I just made it simple so that you understand it. We can make it too complex, but the concept is very important for us. So what did we do here? Simple. We created a task. That task is nothing but we got current thread information and just said that task started and we applied sleep. And we are saying task completed. Just two prints in between above sleep and below sleep. And sorry. And we are saying that thread started, thread completed. Meanwhile, we are also allowing to sleep. That is what this task is doing. In the main, what we are doing this time, you can see we just bit a little bit increased the number of threads we are running here. So we created, see here, how many threads we created? We created multiple threads, at least 5 threads here. Okay, when you try to, you can see this thread object is inside loop, and to this thread object we are assigning this task method. Means 5 threads are running on the same task method. Means 5 thread objects are created with this task inside each thread. And we just updated this saying I plus 1 here. This gives you args, just pass the count here. Like, it provides some name like task one. This name in sense, this argument is passed to name. Just giving that task one means one thread started, first thread, second thread, third thread, something like that. And this is exclusively for having setting a name for thread. Okay, just you can see this is a F string. We just created thread inside that, just passed the again this I iterates from 0 to 4. 5 is excluded. When you say I plus 1, it starts with 0 plus 1. Again 1 plus 1, 1 plus 2, something like that. Meanwhile, we are also creating a list here. All these threads, whichever we are creating, those references we are appending to the list here. Why we are doing that? It's a very simple thing. Just to call join on this these threads. So why should we call join? We will see that. Already you know the reason. While main is in waiting, all other threads keep executing. To keep that main thread waiting, you can see here. So we apply join on this all these threads. Okay, and now you are calling start on each of these threads. Then every thread starts and initiates the thread execution. And meanwhile, we call join on all these threads so that those threads will be running. Meanwhile, main is waiting for its turn to execute. And what we are doing here is we are keeping main in waiting until all other threads are executed. And this is what this code snippet is doing here, friends. So it's a very simple. I don't think with the simple thing we did in the yesterday and today, this is a simple example. Finally, we created driver program and we just segregated all our thread processing inside a main method here. Okay. So this is the idea. Maybe if you run, we get a clear picture here. So what do you do, right? Just call this. Okay. I hope this is clear. Hardly we don't have anything. A task looks like too big here, but we are not doing anything. Simply just printing that current thread information. Which thread is calling this task, that's all. Because we have 5 threads. Among 5 threads, which is that current thread here? Right? It might be thread 1, thread 2, thread 3, thread 4, thread 5. So which is calling tasks. Just to understand that, we just put this current thread name, that's all. Okay. Through loop, we created 5 threads. All those 5 threads again are appended to this list using append method. And finally, we are calling start on all these 5 threads. At the same time, we are running this list and moving all this, calling join all these threads on all these threads, which is on these 5 threads. What is the advantage? When these threads are running, main will be in the waiting state because that is what we want. Right? We want to keep main in waiting so that other threads keep executing. That is what the code is doing here. So let's run this now. So what do we do? Come here, execute this. Oh, sorry. You can keep that as is. What is that I do now? Concurrent. This is a concurrent example. This is interesting. See, again we see parallelism, concurrent test. Okay. So if not that, I think there is a method program I'll do on the list. Let me add that inside. Now execute this and see the understand. 5 threads are created here. That is very clear because we are iterating for 5 times, creating this object inside the loop, which creates 5 threads. And finally calling start on that. Let's run this now. You can see here, sorry. You can see all 5 threads are started. Thread 1, thread 2, task 3, task 4, task 5, 5 threads. Also, you can see the thread name as well. Okay, so all this started. And if you see, task 3 is completed first, and then task 2 completed, and then task 4, task 5, task 1. Again, you can see there is a concurrency. All threads are executing parallelly. There is no order follow. What is not? Order is not followed here because all these threads are in race condition again, right? You know this concept of threading, right? So you have thread one, thread two, thread three. Again, you have one more. You can add two more as well. What is that? Task three, task five, or task four, task five. Okay. So this is actually, you can simply say task, and this is task four, task five. So what is happening here? So here, this is concurrency, right? When you have five threads, all threads will compete with for the processor. This you can see here. We have one processor. One processor has to switch between all these threads. In this process, what is that? First, of course, when you call start on all this, right? If you say start, assume that the start is called on every task. Start here and start here and start here. Okay, like that. We if you call start on each thread, of course, they will initiate threading, initiate executing threads. Now again, what happens? All these threads will be in a queued state again. So once we call start, immediately they get into a queue and they will be waiting in the queue, right? So three, four, five, and we have T1 or task one. Okay, you can say task one and task two. Likewise, you have all remaining tasks. Okay, I'm just adding a dot dot here. That should be fine. Okay, when I say dot dot, task three, task four, task five. Now what is happening? So you in between there will be a thread scheduler. Okay, something TS. If thread scheduler allocates CPU for this task one, if thread scheduler is allocating CPU, then it will go and gets executed by the CPU, and remaining will be waiting. Similarly, same thing. If thread scheduler allocates CPU, go and execute. The gets executed by CPU. When task 2 is executing, again, this task 1 is moved back to the queue. Got it, right? Likewise, the execution follows. Again, task 3, task 4, like that. This is fine. And internally, it uses algorithms like FIFO, something like this, or round robin, something like this, which it deploys, we are not sure. That is the idea. So this is a simple idea, friends. So finally, so in the output also you can see the behavior. This you can at least understand that. Okay. So this is the idea. So we are done with this. Just sharing this with you. This is concurrency example. Executing threads in a concurrent approach using what? Using this simple loop and creating multiple threads. Let me just share this with you. Another is parallelism. That is much more interesting. See, now you will see the difference between both. This is interesting. Okay, what is parallelism? In simple language, see, I just brought it in simple language. What is this? Parallelism is simple, means doing multiple tasks exactly at the same time by using multiple processors or multiple CPU cores. So the difference is simple. Here we have single core, here multiple cores are multiple processors. Here we have single processor. Here we have multiple processor. Let us see this with the example, real example. The previous example is in kitchen. One person is doing all the cooking, that cutting vegetables or boiling water and or baking something or do all this stuff. Got it right? One person doing. But this time parallelism means for each thing there is a separate chef. Got it right? See, you can see that is parallelism. Imagine a restaurant kitchen where one chef is making pizza, another chef grilling burgers, the third chef is preparing salad. Everyone has a dedicated task here, right? That is parallelism. This should give a clear difference between the first example, concurrency, and this. And this in this approach, you don't have issue with that order problem. you don't have missing on order here. Definitely order is achieved here because each one is doing a separate item and their own space, right? There is no point of having interleaved output. Interleaved means something getting in the middle, messed up output. So here, since each chef is working at the same time, the food gets ready faster. And this is parallelism. Each task runs truly in a parallel on a different processing unit. See, every chef is one processing unit, and every task runs in under one process. That is parallelism. How do we achieve parallelism in programming? Simple, right? It is used when a computer has multiple CPU cores. Most of you know this. These days when you purchase a CPU, you see that number of cores, 8 core, 9 core, 10 core, something like that, if you remember. Anybody has idea when you say 8 core, 9 core, 10 core, meaning is at a time it can run 10 tasks parallelly. That is the meaning of 8 core processor. Got it right? 100 cores means at a time it can run 100 tasks in separate processes. That is the meaning of that. Got it right? So generally, this is much more efficient one. It splits a big task into smaller tasks and run them at the same time on different cores. And this is something which makes your execution too faster. If number of cores are more in your laptop or in your machine, and the execution is such is the execution speed, it is directly proportional, right? And this makes programs much faster than concurrency. Concurrency is one CPU switching between multiple items. Definitely, if one person has to prepare multiple items, definitely it takes time. Of course, how fast that one person is doing. If three persons are cooking three different dishes, then they can prepare those dishes much more faster. Okay. And here, when should we deploy this parallelism is especially for tasks like big calculations or data processing. In such cases, this parallelism, especially your data engineering, you are into data engineering, right, friends? For you, definitely more than concurrency, parallel approach is very important. Why? Because
Hello guys, there is a power break, Manaram side. Let's wait for 1 more minute. Yeah, you guys can disconnect. Yeah, we can connect tomorrow.